Hello, welcome back to Short Lectures in Physics. Topic for discussion in this session is circular motion. When a body moves in a circular path, it is said to be in circular motion. Here, speed may be same, but it keeps changing its direction of motion continuously along the circular path. Hence, its motion is described in terms of angular displacement instead of linear displacements. So, angle theta through which it turns in a given time is called angular displacement, and the rate of change of angular displacement is the angular velocity omega. So omega is equal to d theta by d theta. D theta is the change in angular displacement over time interval dt. Similarly, angular acceleration also we can define as the rate of change of angular velocity, that is alpha is equal to d omega by dt. In this slide, consider a body moving in circular path with uniform speed u. So let it be at a position A when time is equal to initial time, that is time t is equal to 0, and from that it is moving in an anti-clockwise direction. At time t it occupies the position B, and at time t plus delta t it occupies the position C from x-axis to y-axis as shown in the figure. The positions B and C are making angles as shown in the figure. So the angle between AOB, O is the origin of the circular path. So AOB is theta, and time interval from traveling from A to B is t, and from B to C the angular displacement is delta theta, and the time interval is. So the body is moving from A to C in a time interval of t plus delta t, whereas from B to C is traveling through delta theta. Time intervals, respective time intervals are t plus delta t and delta t. So this angular displacement in a given time interval of delta t is delta t theta radians or degrees. Generally we mention radians. Then the average angular velocity is given by omega average is equal to delta theta by delta t radians per second. And its dimensional formula is mass is not there, length dimension is not there, hence m0 l0, time is per second, so t to the power minus 1. Its dimensional formula is m0 l0 t minus 1. Well, instantaneous velocity is given by omega is equal to delta t tends to 0, delta theta by delta t is the instantaneous velocity omega, which equals to d theta by dt, what we use in calculus differentiation. Similarly, average angular acceleration, which is the rate of change of angular velocity, phi average is equal to delta omega by delta t radians per second square, and its dimension formula is m0 l0 t to the power of minus 2 because second square in the denominator. Then the instantaneous angular acceleration is given by alpha is equal to limit delta t tends to 0, delta omega by delta t, that is d omega by dt, that is omega is already d theta by dt, so d square theta by dt square radians per second square, instantaneous acceleration of the body at any time t. So the time taken by the body to complete one complete rotation, that is 2 pi radians, is known as the time period. Suppose if it makes n rotations in t seconds, then time period is given by n by t seconds. Then the frequency also we can say, that is frequency is nothing but inverse of the time period, that is the number of rotation it makes in 1 unit of time, that is in 1 second. So frequency is equal to f is equal to 1 by t, that is t by n seconds. Its unit is hertz. Thus the product of frequency and time period is 1. Thus instantaneous angular velocity omega d theta by dt is given by 2 pi by t, because d theta is 2 pi radians in a time period of t. So d theta by dt, that is omega, instantaneous angular velocity is given by 2 pi by t, or 2 pi times of frequency, 2 pi f. Examples of circular motion are electrons moving in orbits, racing cars moving in circular tracks, satellites moving around Earth in a circular orbits, etc. Now let us explore some more description of the circular motion. Let a body covers theta angular displacement instead of d theta, we are saying theta here in a time interval of theta. So it also covers an arc of S, that's as the body moving from P to Q, the arc length is S, PQ arc length is S, and the radius of circular path is R, center is O. So the points P and Q are making an angle theta at the origin, and at any time the body is moving with a velocity u along the circular path. The speed is u, but the velocity is changing because its direction is changing. Always the direction of the uh, body in circular path is tangential to the radius, as shown in the fundamentals, geometry fundamentals. The arc length is given by r theta, where r is the radius. So linear path velocity of the body always will be tangential to the circular path at any instant time and is perpendicular to its radius. Then the linear velocity u and angular velocity omega are related as follows. Because circular path, we have to talk about angular velocity as we do in linear motion with the linear velocity. The linear velocity is rate of change of displacement. So u is equal to ds by dt, but s is equal to r theta already we mentioned. So d by dt of s is nothing but d by dt of r theta, that is r being constant. It is r times d theta by dt, but d theta by dt is omega. So u is equal to r omega. In vector form, u bar is equal to cross product of r bar and omega bar, a cross product. Similarly, linear acceleration A and angular acceleration alpha can also be related as follows. Linear acceleration is A is equal to du by dt, that is rate of change of velocity, which is equal to d by dt of r omega, because u is r omega. So r is being constant, r times d omega by dt, that is r alpha. Thus A is equal to r times alpha in vector form. A bar is equal to r bar cross alpha bar, again a cross product. When a body is moving in uniform circular motion, it moves in circular path with a constant speed v. Velocity is changing the direction. Body covers equal distances on the circumference in the equal intervals of time. Now the body moves at constant speed, the velocity changes as its direction of motion changes continuously. As well as because velocity is changing, direction because of directional changes, the body experiences some acceleration, that is known as centripetal acceleration. The centripetal acceleration is radial and points towards the center of the circular path. So its magnitude is given by S is equal to V square by R. Now consider again the a small section of the circular path in which a body is moving between points P and Q. So the velocity at P is given by Pp bar, and velocity at Q is given by Vq bar in velocity form, because velocity is a vectorial quantity. And its radius is r, that is OP and OQ are the radius r, and making an angle that the arc length PQ is making an angle delta theta at the center. At the time taken the delta t. Angular displacement is delta theta. Then the centripetal acceleration acts towards the center, that is AC. The arc length PQ can be delta S, subtending an angle delta theta at its center. As body moves from P to Q, its velocity changes through delta V bar, whose magnitude is given by vector difference, that is Vq minus Vp bar, is the delta V. Then the acceleration is given by limit delta t tends to 0, delta V by delta t, that is equal to dV by dt in vectorial form. As delta t tends to 0, values of delta s and delta theta become very small. As a result, the magnitudes of velocity components Vp and Vq will be almost parallel and they will be equal in magnitude. Then delta V bar will be perpendicular to both of them and hence it will also be in the radial direction. Thus acceleration will be pointing towards center of circle in radial direction, hence the name centripetal and radial acceleration. So if we see the both triangles, triangle OPQ and PRS, delta V by V is equal to delta S by R. So delta V is equal to V by R of delta S. Delta S is the arc length. As delta T tends to 0, delta S equals to the chord length PQ. Then centripetal acceleration AC is obtained as follows. AC bar is equal to limit delta T tends to 0, delta V by T. That is limit delta T tends to 0, V by R into delta S by delta T. So finally we get V square by R. V by R into V, that is V square by R. Magnitudes of V and radius, velocity component and radius are constants. The magnitude of AC is also constant, but it also changes its direction continuously, but always acting towards the center, but direction changes because V bar is tangential to the circular path and AC bar is perpendicular to the tangent. So both V bar and AC bar are perpendicular to each other at any instant of time. Since V is equal to R omega, already we said, so AC is equal to V square by R omega square by R omega square R 2 pi frequency terms, 2 pi f square R 4 pi square T square R. Thus, when a body moves in a circle of radius R with a constant linear velocity V, the angular velocity omega, the magnitude of centripetal radial acceleration V square by R omega square R, directed towards the center. Because of the acceleration, there is some force acting on the body of mass m. So the centripetal force acting on the body of mass m in circular path is given by F is equal to m omega square R or mv square by R. So this is about the body motion circular path with uniform linear speed. If the speed of the body moving in circular path keeps changing, then that means if the body is moving with certain acceleration, then its acceleration will have two components. One is tangential due to change in its magnitude of velocity and radial centripetal due to change in direction of velocity components. So tangential component will be given by AT bar is equal to dV by dt, rate of change of linear velocity. So the radial component AC bar is given by V square by R. The net acceleration is given by A bar is equal to AC bar plus AT bar, and the magnitude of A bar is given by square root of the summation of these two, AC square plus AT square. Then instantaneous velocity is given by V bar is equal to vectorial form dr by dt, that is equal to d by dt of R bar, that is a d by dt of xi plus yj plus zk. R radius is expressed in vector form, unit vectors. So dx by dt I bar, dy by dt j bar, dz by dt. Okay. That is the velocity components in x direction, y direction, z direction. So dx by dt is vx I bar, vy j bar, vz k bar, and its magnitude is given by square root of vx square plus vy square plus vz square in terms of scalar components of v bar. Similarly, instantaneous acceleration is given by a bar is equal to dv by dt, that is d by dt of v bar, that is d by dt of vx I bar, v plus vy j bar plus vz k bar, that is equal to dvx by dt I bar, dy by dt j bar plus dy by dz by dt k bar, that is ax I plus ayj plus azk, where ax, ay, az are the magnitudes of velocity in the x, y, z directions. So the magnitude of a bar is given by square root of ax square plus ay square plus az square in terms of scalar components of a bar. Consider a pendulum which is in oscillation about its mean position. Let us see what happens when the string of the pendulum is cut at different positions. When it is cut, when it is at the mean position, the velocity of the bob is maximum at its mean position as it is swinging. Hence, it, it follows a parabolic path with its horizontal velocity. If it is cut at its when the bob is at a maximum position, maximum height position, then it falls like a freely falling body, because at its maximum position velocity becomes zero, and hence it falls like a freely falling body when it is cut when the bob is at the maximum position. So with this we have discussed a few points in circular motion. Let us see its applications in solving some of the numericals. Now Earth is making one revolution in 24 hours, as all of us know. The radius of Earth is 6.38 into 10 to the power 6 meters, that is 10 to the power 3 kilometers. If a person standing on the equator, then his experience, how he feels, is to be assessed. So the number of revolutions is 1, and time taken is 24 into 3600 seconds, because hours has to be converted into seconds. The radius of the angular speed is equal to omega is equal to 2 pi by t. That is 2 pi by 24 into 36, so that is 7.3 into 10 to the power minus 5 radians per second. Tangential speed is equal to v is equal to r omega, that becomes 460 meters per second. Now a satellite is put in circular orbit around the Earth at an orbit height of 200 kilometers, where the acceleration due to gravity is 9.2. We know that g varies with height above the surface of the Earth. Given radius of the Earth is 6400 kilometers. Then the radius, because our radius of Earth is 6400 kilometers, plus height above that for which the satellite is in circular orbit is, so radius of the satellite's circular orbit is given by 6400 plus 200, 6600 kilometers. That is 6.6 into 10 to the power 6 meters in scientific notation. Then centripetal acceleration of satellite is given by AC is equal to v square by r, that is 9.2 meters per second square. Then speed of the satellite is given by v is equal to square root of ACR, that is equal to square root of 9.2, because g is that orbit height is 9.2 meters per second square, into r is 6.6 into 10 to the power 6, so 7.8 into 10 to the power 3 meters per second. Time period t is equal to 2 pi r by v, that is we will get 5.3 into 10 square days, or 1.47 days. So for Earth it takes 1 day, but for the satellite it takes 1.47 days to complete that circular orbit for one rotation. The particle of mass m is moving in a circular path of radius r such that its centripetal acceleration AC varies with time, as given in the formula AC is equal to k square r t square. Then the power delivered to the particle by force acting on it can be obtained as follows. AC is equal to v square by r, that is equal to k square r t square. AC is equal to k square r t square. Thus v is equal to k r t. Tangential force F is equal to ma m dv by dt, that is m dv by dt of k r t. Velocity is k r t. So d by dt of k r t, that is equal to m k r. Power delivered is equal to force into velocity. So mkr into krt, that is m k square r square t square. Now a car is moving on a circular track of 500 meters at a speed of 30 meters per second. If its speed is increasing at a rate of 2 meters per second square, then its resultant acceleration is. So because the linear speed is increasing at a rate of 2 meters per second square, accelerating, so we have two components, centripetal and tangential forces, accelerations. So centripetal acceleration AC is v square by r, that is 30 square by 500, 1.8 meters per second square. Tangential acceleration AT is given as 2 meters per second, already given. So resultant acceleration is A is equal to square root of AC square by square root of AC square plus AT square, that is Root of 1.8 square plus 2 square, that's 2.72 meters per second. Hope you got some idea about circular motion and the application of the points discussed in solving some of the numericals. Hope you enjoyed the video. See you in the next session. Till then, bye.